can get our SI unit like L, which is length, having meter, then T, which is time, that's per second. Do you understand that? Good. So for our acceleration too, we can do the same thing. Our L, which is length, M, T, which is time, then per second square. Hope you get that. Alright, for our force also, M is kilogram, mass is measured in kilogram, length meter, and time per second, which is still equals to Newton. Hope you get that. So for our pressure, we have our force, which is Newton per meter square. I hope you get that. Good. So let's talk about the how to get for other quantities, how to get the dimension for other quantities. We have two methods that we use. We have Rayleigh and we have Buckingham-Pi method. Pi method. But in this class, we'll be using Rayleigh's method. Buckingham-Pi method is beyond the scope of this class. So follow through as we explain. Alright. Cut. I need to bring out. Alright. We are using Rayleigh's method to solve the question here, so as to get the correct equation for the formula. Alright. The speed c of ocean waves is proportional to the acceleration due to gravity g, wavelength lambda, and density rho of the wave, such that c equals k g raised to power x, lambda raised to power y, rho raised to power z, where k is a dimensionless constant. What is the correct equation? Alright, good. From this question, we can see that we have our formula. Alright, solution. We have our formula C equals K G raised to power X lambda Y rho Z. Alright, good. Now we are told in the question that K is a dimensionless constant, meaning K does not have any dimension, does not have units, does not have dimension. So we take it as a constant. Alright, good. And we were told in the question that C is speed. Like we did the other time, velocity equals what? L to the power minus 1. The same dimension as velocity, also speed. Though we are coming on other vector and scalar to explain the difference between velocity and speed. Alright, good. So our speed is same thing as what? Lt raised to power minus 1. Hope you get that. Good. Lt raised to power minus 1, which equals to K is a dimensionless constant. Now G is what? Acceleration due to gravity. Like we said the other time, acceleration is what? Acceleration equals Lt raised to power minus 2. Good. The same thing applies here. So acceleration due to gravity is what? That's Lt raised to power minus 2. Minus 2. Alright, all raised to power x. Hope you get that. Now, lambda is what? Wavelength. From the word wavelength, it's telling us that that's the measure of what? Of length. Good. So our lambda will be what? L raised to power y. Hope you get that. So the last quantity we have here is rho, density. Density rho. That's the Greek word for this symbol, rho. Good. So density, from the formula, that density equals to mass all over volume. Remember? Yeah, good. So, and our mass is what? M. Our volume, that's what? L raised to power 3. Okay, this is it. Mass equals to M. The volume, remember, is having L times L, which equals to LQ. Hope you get that. So then we can say our density to be equals to m over L cubed. This is the dimension for it. Alright, good. Let's now input it into our equation. So then density rho equals to what? M L raised to power minus 3 from indices. Hope you get that. So Z. Alright, now one thing we are doing here is to compare both the right hand side and the left hand side together. That's the beautiful thing about mathematics. We try to justify the left hand side with what? With the right hand side, so we can have a balanced equation. Good. Alright. L T raised to power minus 1, which equals to K. Remember, K is dimensionless. Alright. X times X times T raised to power minus, that's minus 2x, dot L raised to power y, hope you get this, yes, dot M raised to power z, L raised to power minus 3z. Alright, good. Now, you know we said we are comparing. So by comparison, we are having m raised to power 0, L T raised to power minus 1 to be equals to K L raised to power x, T raised to power minus 2x, L raised to power y, M raised to power z, L raised to power minus 3z. Alright, good. So now you bring m, you compare m to m, L to L, T to T. That's what we are doing next. Alright, so m raised to power 0, left hand side, this is my left hand side. So m raised to power 0 will be equals to every of the m variables here. So this is equals to m raised to power z. So m chop out m. So we are having z to be equals to 0. So we've gotten one of the what? Powers. Z equals to 0. Let's keep that. Now let's try to get for the other variables too. Let's say m. You know, here in my left hand side here, I'm having L to be just raised to power 1. So let's say L raised to power 1 equals L raised to power x. Okay? We are having some variables for x. Okay, yes. Dot L raised to power y dot L raised to power minus 3z. Remember from your indices. So we'll be adding up all this power and just taking one base of L. Okay, good. So having L raised to power 1 to be equals to Lx plus y minus 3z. So L chop out L, you're having x plus y minus 3z to be equals to 1. Let's keep it. Let's say equation start. Alright, good. For the last one, t raised to power minus 1, which equals to, we have one function of t here, yes, and I think that's all that we have, yes. T raised to power minus 2x. So t chop out t. You're having minus 1 to be equals to minus 2x. So by division, we can say x equals to 1 over 2. So we've gotten another value for our power here. Let's say equation star. Alright. So input equation star and equation 1 into equation star. Alright, good. So x plus y minus 3z equals to 1. Remember that my x is what? 1 over 2. Plus y minus my z is what? 0, which equals to 1. So 1 over 2 plus y equals to 1. Since this one what? Will be going to 0. Alright, so my y now equals to what? 1 minus 1 over 2, which equals to 1 over 2. So like that, therefore my y is what? 1 over 2. Simple. We've gotten our x, y, and z, but we are yet to be to get our equation. So let's get it from all of these powers we've gotten. Alright, good. Remember from the question, we are having our c to be equals to k g raised to power x, lambda raised to power y, and rho density raised to power z. So we input all of the values of x, y, and z into all of these quantity, so we get our final equation. So C equals to K is dimensionless constant, good, and G, what's our x? 1/2 lambda. Y, our x is 1/2 and our y is what? 1/2. Rho z is what? 0. Remember from mathematics, anything raised to power 0 is what? 1. Good. So we can say our equation of wave, the speed of wave of the ocean rather, equals to K g raised to power 1/2 lambda 1/2, which can also mean C equals to K square root g lambda. I hope you get that. How do we arrive at this square root? Remember in mathematics that anything raised to power of half, the half there is the square root. Hope you get that. So we are having half, g raised to power half, lambda raised to power half. They are both having the same common factor, which is half. So we have to put it together as in just a canopy. Yes. So they are living under the same roof, which is what? Square root. Hope you get that.